As people get seated, my name's Jesse Robbins. I have known Brady for a very long time. He helped me start the O'Reilly Velocity conference, which is where we got DevOps and the infrastructure as code movement and sort of a lot of core internet culture in the early days. I was fortunate enough to start an open source company called Chef, which sort of powered a lot of the global infrastructure. Before that, I worked at Amazon and learned a lot of things at Chef, including how important it is to have the right investors backing you, particularly when you're building things out at scale, which is, of course, what this session is going to be about. And so I am now a venture capitalist trying to undo the harm that was done to me in the first time around. And honored to work with other folks. I think GenLab is a very exciting approach, and so this group of people is interesting, small but mighty as an event, and very, very high quality folks here. So I am also looking forward to networking a little bit. Purpose of this panel is we're talking about scalability, and actual deployment and infrastructure from really kind of three perspectives. One perspective is what is actually happening in successful organizations that are reaching any real size, and what shifts both in terms of the engineering, the culture, the HR people and process. And then as we sort of move through that stack, we're then going to talk about how we both power and pay for these shifts in these enormous environments. Everyone that's on the panel today is actually deploying today at scale, so we are not the theory prognostication panel. We are the actually doing things and telling people how to do things panel. So feel free to inject questions at any point if you'd like us to answer anything specifically. I'm going to start here with no relation. Go ahead and introduce yourself, and then we'll get going. And short intros. Okay. Otherwise, Brady's going to ring the gong.
Okay. My name is Charlie Robbins. I've been focused on...
No relation.
Yeah, no relation. No relation. We can just show it by the previous names.
That's right. Yeah.
Currently, I'm a senior advisor, engineering leader at Plus Power. They're a utility scale energy storage provider, so very, very large batteries in front of the meter. About 1.8 gigawatts deployed, 10 gigawatts in the pipeline. So I think Tesla Megapack, those things, Sungrow batteries. Before that, have been in technology a long time. Did NFTs for a little bit. Before that was in Node.js project, helped start the Node.js Foundation.
So the most popular programming language?
Oh, it's just a little thing we did there for a little while.
Okay, quick show of hands. Who has more than 1 gigawatt of power under their direct control right now in this room? Just you?
I can't go send the dispatch signals, but right. I would get called if something went wrong.
There we go. All right.
All right, I'm Jason Gecki. I'm a multi-exit co-founder and CEO. That led me to work at Cisco, where I was part of the WebEx team, and then Intel as well, where I learned a lot about semiconductors. And now I'm doing advisory work and working on a lot of different AI and ML projects at the moment.
Amit Govrin, co-founder and CEO of Kubia AI. My relationship to Jesse is we share the same board. As one of my investors, Jesse and Heavybit, and also Daniel and Brady. So we've had a very good fortune of having the greatest investors.
Don't screw this up.
We're going back for another check here. Just kidding. My background is also in the DevOps and infrastructure domain. So prior to founding Kubia AI, I was head of a global segment for DevOps and DevSecOps at AWS. Prior to, I was actually in the early days of the FinOps movement. It was called Cloud Analytics at the time. We were defining category, Cloud In, so now part of Microsoft. So I got to see the whole life cycle of the DevOps movement from the system admin days up until to what we're now saying, the various categories of the DevOps. So it's thanks for having us here.
So the first question to toss out is the simplest one. What what right now is the number one pain point that you are seeing organizations go through that are actually deploying inference AI at scale? So not in a dev test environment, but actually in production. Like, what is the number one thing right now, so that everyone here knows like what the problems are? You go first. You're exited.
Oh, me or you?
You.
Okay, no, I'll go.
I'll go after.
I think the biggest thing I'm seeing right now is people being able to find the talent that know how to do these things and go and deploy at scale. It's still something that's fairly new, and there's a lot of training and work that needs to be done to get people inside companies up to speed and then out in the market as well.
For me, it's that AI doesn't solve everything. In the energy industry, there's a set of mixed integer linear program problems. They call these optimization problems. So you use AI to get the forecast for the energy products that you think you're going to trade, but then you have to do an optimization on top of it. So how do you sort of take AI outputs and then use them effectively in a trading system?
I'll zag a little bit. I'm actually talking about the architecture considerations. I'll take it one step back. We talked about FinOps a second ago. One of the early revolutions that I've seen in the cloud, the early days of lift and shift of data centers into the cloud, is how do you go and get all these workloads in a monolith into distributed architecture, and of course, how does that scale? Not very well if you're not architected correctly. And what we're seeing now in our own domain is how are people architecting their GenAI applications? The short answer is it's not just going and plugging an API into a public provider and seeing how it scales, because it's like running essentially an entire data center and on-demand pricing in Amazon. It doesn't scale that way. There's a lot of architectural considerations. We're talking about model selection, we're talking about inferencing and function calling, and we can go into the list of all the different considerations. If you're not architected correctly, you're burning away money. And it's also inefficient from an energy perspective as well.
What's actually working?
What's working for others or for us?
Our customers. Like, what are large organizations that are scaling? Like, what is actually working that you're seeing in production today?
Cloud-native architected third parties. So if anybody uses Snowflake here, Snowflake is a great example of this, where they just provision some AWS things. You're talking about the language of AWS resources as opposed to a counterexample, battery telemetry. These batteries emit a bunch of data. The vendors that sell these batteries, they want to kind of lock it away from you. And so just think about the wasted energy. They have all the same AWS infrastructure that we do, but it goes all the way through the pipe to their API that we now call. When if we had, say, an ARN to their Kinesis Firehose, we would be saving a lot, we'd be a lot more efficient. But nobody in the vendor space is thinking about it that way.
Interesting.
What I'm seeing is people rely a lot on the cloud providers to provide the tools to do their AI work rather than try to deploy internally while they learn, with plans to eventually deploy it internally once they get a good feel for what their application usage is.
From our perspective, I think it's more about expectation setting. Today, what's been very popular and actually productionized in many respects is retrieval, augmentation, generation, right? Like retrieval of information, querying data sources, and so on. We've had a few people present about that. That's been working very well because it doesn't have any life-changing event. If now you have to take a decision that may actually take down a production environment, that could actually have a different second-order effect. So we're seeing that's kind of that next level. The action taking is really that next level of, I would say, how should I say, the risks that people aren't yet comfortable with. So we're seeing more around retrieval of information being the first one. Yeah.
One of the things, the common threads I've seen over the last 18 months or so is a real intense belief that we are right around the corner from having basically like trust and safety solved, and that the AI problem that it creates will have an AI solution. And it's been very interesting to see this life cycle where, as the other panelists before were describing, we have this new data pipeline, we're producing this new capability, and then on the other side of that, we have this problem where it doesn't produce the same results every time, or things change. Two things that came out of an event that Brady and I ran last year was your prompts are the new lock-in, and this is something that a lot of developers are discovering, and now enterprise are discovering, to your point about batteries. And the second is that the data pipeline is kind of the new secret sauce. And so that set of things, as we've seen across the board, every time with every organization, enterprises are discovering that lock-in, and they are now discovering, like, literally there's a new capability that nobody else has. Question from the audience.
I hate to take it backwards a second, but you guys were all talking about, and I've seen this myself, people relying on the cloud providers for their native tools. What do you think about NVIDIA entering this space and trying to be generally neutral? I've heard very mixed reactions from that. I'm kind of curious.
The question is, what do we think of NVIDIA entering as a neutral cloud provider?
As a neutral API provider, they have now offered a neutral API that you can run on any cloud or on your own that abstracts away, in theory.
As long as you're running NVIDIA.
Right.
Yeah. Thoughts?
Yeah, I think you're referring to NIM that they have.
Exactly.
Yeah. And I've used it myself, and I think now they've also come out with Nematron, which is their own foundational model. So I think they're going to go squarely at the rest of the folks and keeping the video on top of everything by providing an ecosystem themselves.
For us, it doesn't affect us. We're cloud agnostic in that respect. I think it's really the customer choice. If they're comfortable having NVIDIA own the whole stack, we're comfortable with that as well.
Yeah, it doesn't necessarily apply to the world where primarily time series forecasting and optimization, but I think generally speaking, you look at portability of workloads. Let's look at something like Kubernetes for the last generation of cloud. I think portability in general is going to be important, but people will generally go where their data is because there's a gravity that pulls it in.
You're suggesting that S3 is a lock-in for Amazon? Outrageous, outrageous.
I was going to say, and Qualcomm has nothing to do with ARM anyway.
But I do think the video move will just bring the Department of Justice to them quicker as well.
Oh, interesting.
Yeah.
One of the questions that we've seen, or one of the things that we've seen a lot as organizations make this shift is a new skill, right? And it's an old skill. Like who here has ever been in a data center? Raise your hand. Okay. Who here has been in a data center in the last 10 years? Okay. So who's been in a data center in the last 2? Yeah. Now that might be that we're all succeeding in our careers, and so some other poor sucker has to go to the data center. My last time going to a data center was the Amazon data center that I got to power down in Seattle, which was a personal point of pride. That was 2005, and the interesting thing is that now we are seeing organizations saying, "Yep, we're gonna build our own cloud environments and GPU environments out," and it's a totally new thing that they're able to do, and it's definitely not something that we all forgot. So how is that? How are you seeing that roll out in terms of, particularly your customers, where you're actually advising enterprises, saying, "Yep, this is what we're doing." Like, are they actually putting in $20 million orders with NVIDIA?
No, again, what I'm seeing is a lot of the use of the cloud
today,
and doing their inferencing there. And if they are going to be doing training, then that's where they start to invest.
Interesting.
As well.
How about you?
In addition to Plus, I advise a company that's commissioning data centers in India. And so one of the things I think that if you told people 10 years ago you'd start needing PPA, power purchase agreements, for your data center, they would have laughed you out of the room. Like, oh, I put my data center wherever nodal prices look good. But nodal prices are changing so quickly. People are saying, okay, well, if I can't commission this solar in this ISO, then I actually need to be putting that data center in the United States near liquefied natural gas resources, because those things are where I'm going to get my variable workload. Whereas in a place like India, where there's much more favorable policies for commissioning solar, I can get my data center and I can get it on green energy, because that process is a lot easier than it is here in the US.
Right. We're seeing mostly the third-party applications having a requirement to deploy on the customer side with the customer inferencing, hosting their own vector databases, even bringing in their own API keys for language models. Nobody actually wants to go and take that out. So the biggest challenge is really about how do you do local deployments with having the eyes on the customer deployment and being able to have that essentially persistent connection back to the control plane on your side. So we're doing that. It's really hard, let's be honest. Kubernetes based, of course. But that's one of the biggest challenges. No Fortune 500 company will allow you to go and to train on their data and your side of it. These are not consumer apps, right? In many respects, that's where the line is drawn. Mostly enterprise applications require everything to go on their side, and that's where I think the hardest challenge to solve is right now.
I want to talk briefly about, I think, the shock at how quickly we, for instance, reactivated 3 Mile Island so that Microsoft could have data center power, which shows an interesting infrastructure moment. But those of us that have had to buy multi-megawatt or now gigawatt level power commits in order to power their infra, how quickly is this all changing? It feels fast.
It's very fast. For folks who are less initiated in the energy industry here in the US, there's a lot of assets that are owned by an owner-operator like Plus, and then the ISO pays them to provide power. So
Say what an ISO is.
Independent systems operator. So here in California, that's CAISO. New York is NISO. There's, I think, 9 of them in the United States. To give you an example, there are 2 projects in SRP, the Salt River Project. This is Arizona and New Mexico. There are 2 very large projects, about 500 megawatts that we commissioned 2 months ago. But it's owned by Plus, but it is PPA'd for 20 years with SRP. So that need of oh, actually, well, how does the energy work? Wait a minute. You don't own it, they're actually paying other people. That knowledge of pulling behind the scenes is going to be way more important in the next 10 years than it was in the last 10.
During my time building stuff at scale, now that VC, who even knows what I do, but there was a day where we made what we thought was the coolest secret heat map, and it was power availability, connectivity, geographic stability, and tax policy. And depending on which company you worked for, the stack rank and colors changed differently. I worked at Amazon, but we pulled up into Quincy, Washington, at basically the same moment that Microsoft and Google also arrived in Quincy, Washington. And suddenly we were all building data centers in Quincy, Washington because of there was hydro availability and a bunch of other things. And it seems like we're going through a new wave of that, where now, what you just described, except now it's much more global, which is a new shift, particularly for companies that are now paying taxes in more traditional ways. Before they were more innovative with the way that they were doing that. What do you think that's going to look like in the next year or two, in terms of big power buys and scale-out buys?
That's a great question. I think that, again, people are either going to go towards, so there's 2 workloads here. Inference, which is the one where you're using ChatGPT, and training, where the foundational models get trained. Inference, you want to be closer to your customer because you want to give them that response quickly. Training workloads, they're much more resilient to latency, so you could potentially train your models in India, train your models in a place where it's very easy to commission the energy assets for your data center. But your inference data centers in the United States, I think it's really going to...
Wherever the closest is to your customer.
It's going to be a function of how well the U.S. can start commissioning the energy assets that they claim they want. The Inflation Reduction Act here was dramatically transformative for businesses like Plus. It allowed for tax credits to be transferable. But if you don't believe that you're going to get the approval of the local permitting board where you're going to commission that solar, you might locate it near where solar is good and there are liquefied natural gas resources, because the inference workload will go up in the middle of the day, but the training workload will be consistent.
Interesting. So, there's going to be a bunch of areas. Oh, yes.
Thanks. Everyone up there is, at some level, an incredible leader in the DevOps world. And I state that because when we thought about putting this panel together with all of your experience and understanding we're putting $630 billion into energy, we are building 8,000 data centers. That doesn't include the foundries. That doesn't include the chips they're building out. In a world, and Charlie, you probably feel this to a certain extent, energy is not a iterative organization. That is a very slow-going waterfall. My question is, can we learn anything from the DevOps world that your collective experience shares that could help us build faster?
That's a great question. I think it's going to vary a lot by regulatory preference. So, for example, if you're going to say, oh, I'm getting battery telemetry data, you can get that data in AWS. You cannot send control signals to your asset. So turn on, turn up, ramp down. You cannot send those from things that do not have a certain regulatory compliance, which AWS does not. But that doesn't matter for most systems. That's really the ISOs themselves who are sending, hey, battery, give me more power. Hey, battery, give me less power. Hey, gas plant, turn off.
I mean, that's true for every regulated industry. Right. There's colors of data storage and compute.
Within the assets, right, because these assets like solar, they call them DERs, distributed energy resources, they have a lot of computing within them. I think within them you can see this benefit of DevOps doing it more modularly, but you're in a world where you're trying to convince people not to rack in a colo, right. and that is where you start.
Yeah, and what I think is going to happen is, it's been, decades since we built a nuclear power plant in this country. And we've probably forgotten how in many ways. So I think the move is going to be more towards modular nuclear that get off the grid rather than be on the grid and be able to run your own power plant for the data centers. I think that's where it's going to go, and you can get much more agile when you do that.
So I think you asked a question, but there's two aspects to it. One aspect is the units. In order to get the units economics right, there's one aspect which is the cost of energy and manufacturing. The other one is better efficiency with what you already have. If you're better optimized for workloads, if you're better optimized for really running on edge and the full stack, the application, the infrastructure, and the UI area, you'll have more output on the other side, and you can run a more efficient business, and of course have more customers with existing workloads. So.
One thing I wanted to add, for at least in the United States, is that tech companies are very good at managing governmental loan processes. So what the Inflation Reduction Act created was, I think it's a $480 billion fund in the Department of Energy. They do not fund pure software, but they will fund software as a part of commissioning an asset, these types of things. So I think as the larger tech companies transition to be hybrid energy companies, they'll be well positioned to extract and help the US government deploy those funds, which they have not to date been able to deploy very much of.
And I think it's not just energy. There's, when you look at an availability zone, there's a certain density on the grid that you can get off that where your data centers are. So there's other technologies like hollow core fiber that will give you 50% more speed, so you can spread out your availability zone and get access to more power, be more resilient, everything around that as well.
I'm going to take us in a slightly, go ahead.
Just a quick question to follow up on that, especially as you're going towards globalization. And I'm biased a little bit because I do work with the DoD quite extensively. How are you accounting for conflicts? Ukraine never thought that they were going to face what they did, or that suddenly. I mean, there were predictive models for that. But in addition to that, we're also headed towards water shortages, mass migrations. I know it doesn't seem like it's going to happen in the next 2 years, possibly not, but next 10 years, absolutely, right? And how are people truly talking about resiliency?
All right, so just to make sure I'm clear, in the next few minutes, what we're going to do is we're going to answer how to solve for all global political.
Not all, Jesse.
Yeah.
Are we at least are the, folks like Charlie thinking about where we're headed and how do we build resiliency? right?
The water shortage is a really important one. There's a fact I wanted to call out to this group of about every 5 requests to ChatGPT is about a 16-ounce bottle of water that needs to be cooled. So as you get more of these data centers, it's not just the chip, it's not just the polysilicate, you also need access to water. Desalinization, right? That water can be reused, so I think there's probably a place to look at there if you had.
Heat some hot tubs.
Yeah, exactly. I think finding a way to reuse that hot water, about a third of the world's energy is spent on heat. Maybe that's an interesting thing to start thinking about. But as, like you mentioned modular nuclear, I'm not against nuclear, but the interesting thing about it, everyone talks about the need for firm power, but these inference-based data centers, when everyone's asleep, they don't need that power.
Yeah.
So the distributed energy resources actually scale well with batteries, scale well to how we actually use things in the world. If load shifted by 4 to 8 hours, and you can actually get what you want. Plus, you'll get the IRA, ITC credits that you wouldn't get with a nuclear reactor.
Fair. Yep.
I wrote the DR policies for a former employer whose name I'm not going to say. And at the time, that included the underwriting for Lloyd's of London for the business that I was working for at that time. Not going to say exactly who it was, but they sold books online. And at that time, when I wrote that policy, it was like, well, here's all the things that we're worried about. And you get into like whether a second tactical nuke in a particular data center ring in a certain area would be a force majeure event or not, right? And so to answer your question, risk management is a thing that every major provider thinks about, but within a certain framework and construct. And as global risk changes over periods of time, people become, you understand resiliency more and more. The thing that I think is true for everyone that is experienced at scale is that there are certain things that there isn't a risk model for. The water availability one is fundamental. There are other elements that are similar where you just have these epic disruptions, and the truth is that it is an unfortunate part of consideration of application and infrastructure design, and it's part of why you see an increase in focus on these distributed models and getting capacity closer to people and sort of all these other things. You end up building monocultures. Monocultures are dangerous. And so there is an awareness of literally every organization that you talk to that reaches a certain size. Unfortunately, that's also tempered with practicality that means that it can be hard to sort of get into that headspace except when there's a major compelling event. So I think the answer is yes, people are aware. Fair enough. But the question is what timescales and what risk models. And it is very challenging to be able to say, yeah, we're going to operate in a world where there's just not enough cooling available or enough water available.
I'm personally looking at the cable from Australia to Singapore, right? If that works, it will be a level of distributed solar or distributed energy that we've not seen before. And the classic canonical example of like if you just put solar on the Sahara, you could power the whole world, but the distribution problem has been very challenging to solve. So I think that's supposed to come online in the next couple of years. If that works and that scales, that'll be a really fascinating way to think about international energy transfer.
How do we do on the existential? Okay. Any other questions? I'd like to, how much time do we have? Oh, we have time. I'd like to take a slightly different direction. One of the things that you shared while we were talking is some interesting social shifts around, this is going back into kind of the DevOps adoption, and when we start seeing large organizations adopting things like agents and agentic models. Can you talk about like what it's like in Fortune 100 where you suddenly deploy, I mean, obviously this is your product, but sure. Like the social response to having a bot in the loop with the humans?
I think there are 3 levels of the agentics. We'll go with the first one, which is the co-pilots. Everybody's familiar with the co-pilots. That's kind of where you have a human in the loop and you're constantly having kind of human-paired operations, so either code completion, text completion, it's typically requiring at least something in the loop or somebody in the loop in order to complete that operation. And it's very useful for what it's worth, but you can't let it go autonomous. So then the second level is really the autonomous agents, right? You can go from lane chain and kind of lane graph and all the various frameworks, but at the end of the day, these are statistical-based models, multi-agent systems that are interacting with one another and going off to complete tasks. There is a challenge, and we experienced this on our own so we built our first agentic framework about a year and a half ago. So it was even before Mark Benioff.
Before it was cool.
Before Mark Benioff made it cool. But in other words, we've already experienced all the production challenges that I believe a lot of the people building today are going to be experiencing, which is how do you control? How do you exert a level of control and predictability so that it doesn't go and install a bash script and go into God mode and go and do whatever it requires it to do? You're not going to pass your next SOC 2 report if that's the case. So there's a lot that goes into building these models where you can refrain it from, so permissioning is a big piece of it. You need to know what sources and tools to connect to it so it doesn't go into areas that it shouldn't. That's part of data sovereignty, that's part of data governance, and so on. There's so many elements that go into this, I would say, building these agents where you can go into production. So we've already experienced, if you let it go unsupervised or you let it go into a crash loop back off and start burning through your entire tokens, people are going to lose trust. They're going to throw you out. It's just not going to be moved into production anytime soon. So we're seeing a lot of these challenges. Like I said, the first order effect, which is the co-pilots, which we started with, of course, the agent system, and now we're going into AI teammates. We're kind of branding it. It's not a commercial. It's more about the next order effect is how do you go and you take the decision making out of the AI and make sure it's all grounded with code. Everything needs to be controllable, predictable, and perfectly clear. So 100 times out of 100, not only do you get the exact result, it gets there exactly the same way.
How do humans react? This is
yes.
How patient are people while your new teammate is running around in your enterprise doing stuff?
Not very.
Talk about that.
If you want war stories, I
No,
got plenty.
I want to make this real. Like, this was so shocking when we ran into it. So,
one of our customers, for example, did a prompt that set one of the agents, again, I'm talking about 6 months earlier, that sent it into, like I said, the loop, and it burned through about $2,500 of credits in less than 24 hours. Again, it was a small sample, it's a large enterprise, they have the budget, but they weren't happy with the result. And of course, what we had to do is we had to take the prompt engineering aspect out of people, because that's where the skill set comes in. Oftentimes, you can say, oh, you could just talk to it, but prompt engineering is a skill. You need to be able to master it in order to get the outcome you want. And oftentimes in enterprises, especially when you go down the lower tiers of the service providers, you don't necessarily have the same skill set, and there's a skill gap. So you need to be able to kind of create a framework that the skill gaps are abstracted away from the actual underlying infrastructure.
And match the tasks and capabilities. So in this world, the forecast horizon for time series, like going beyond sort of 48 hours is very difficult. But the 48 hours is the weekend. So if you have a trading desk that is responsible for actually clearing bids, they might override your agent all the time just so that they don't have to worry about it on the weekend and they can just check out on Friday.
Precisely. Or an agent times out and then resets itself, and then you have a net new response with the new pod that goes up. So there's a lot that goes into that. Again, you have to manage it with pure platform engineering practices. You need to use IAC, right? Terraform. You need to use Kubernetes and schedule tasks and all the familiar tools. And you can't reinvent the wheel for the operators because you'll lose their trust. Nobody wants a black box that just does magic for you. They want to know exactly what goes on behind the scenes. They want to be able to touch and see the code before they'll go and deploy it.
one of the thing I was trying to get to extract from you, so I'll do it, is so you'd have this magic capability that works. It's doing this powerful DevOps automation. Delegation is the new automation, is kind of the model. And so we're in a customer environment, and I'm trying to figure out, like, this was before I was investing, but I'm like, is this really going to work? And the customer feedback was, well, yeah, no, I told it to go do this thing it was a series of tasks, really mundane stuff that sysadmins hate doing, that infra engineers never do, and it takes about 4 hours to do the work. And so they're like, great. And then 4 minutes later, the customer is like, well, it's not done. It's like, well, no, it's a machine that is running the thing. It still takes the same amount of time. And organizationally, they're like, well, but the AI's doing it now. It's like, no, you're still running the same process. And so when you think about that, and you're like, okay, well, now we're going to be running this constantly, or we're going to run them in mass parallelization. You think about what coming back to that, every couple of queries takes up 16 ounces of water. Humans are going to want to run this machine a lot because we're impatient, and workload management and prioritization suddenly becomes extremely real, and none of us are good at giving things time to complete. I'm a frequent refresher when it's there. And so every human behavior that we have, that particularly in systems that are working, we're going to see expand out. And so your power problems and your customers' strategies and your customers are going to see exponential growth every time we get something right in AI. And so, Daniel, I don't know that $680 billion estimate is accurate. I think we're going to see more and more go, and the power needs are going to go accordingly, just because when it works, now we have an entire new work stream that enables us to focus on really important work. Any other questions from the audience before we wrap up? Go ahead.
Have you ever seen any resource that would say, given this prompt, it's going to take this many resources to provide you that answer?
The halting problem. Yeah.
There's a newer startup called Workflow AI that's started by the folks that ran Sunrise, and what they'll do is they can't tell you a priori like an Oracle because the halting problem, which I'll spare you all the theoretical computer science, but they will
The answer is
give
it's
you,
not possible.
Yeah. But they will give you okay, well, given this prompt, run it on these 5 providers, and how much did it cost? And then you can say, okay, well, if you run it on the O1 mini model instead of the O1 model, you get the same accuracy. It's 99% accurate for the 10 examples that I gave it, but it cost me 10 cents instead of $1. So it's like sort of a farming out.
We actually do provide. So we know exactly the token usage you'll need because we're using infrastructure as code, it's all predictable, it's repeatable. So we can go and apply that as well.
Any last questions? I think we covered a lot. Thank you.
All right, thank you.
Awesome.
Thanks, everybody.